Hi, I'm Louise Hamot, working at Elementa, and I'm going to talk about the Bullet Center, which is a commercial building in Seattle, finished in 2013, and situated in the middle of Seattle in a semi-dense urban context, I would say. It hosts the headquarters of the International Living Future and Institute and other tenants. It's mostly offices, but the first 2 floors are for educational purposes concerning living buildings. It is actually full living building certified, said to be the greenest office building in the world, at least one of the highest living buildings. And I will highlight some of the pedals he addressed, and I would like to start with the fact that it's achieving net positive energy and net zero water. And you can see that actually the EUI and the water consumption for this building are pretty low. Concerning the energy use intensity, it is actually making, compared to an average commercial American building, it is actually 83% lower, and the actual performance is lower than the predicted one. This can be verified through constant monitoring, which takes place inside the building, and you can find this information on the website. And as Martin said, we're saying again that certification is based on actual performance and not modeling and predictions. So if we look at the energy pedal and how the building actually achieves net positive energy as it is required, the better way to explain it is to compare it to how a tree works. Like a tree, it harvests energy from the sun through PVs, and the PVs have been laid out to maximize yield during summertime, because in the summer it gets very, very sunny, and a lot more sunny than in the rest of the year, and they find out there was the biggest yield. And therefore the grid is used as a battery. The surplus in the summer goes into the grid, and they get it back in the winter. You can tell that the roof area creates a large canopy and exceeds the footprint, and it's something they actually had to change the building regulation for, because it was not allowed by the Seattle. And it provides shading, but also it allows light to go through a series of holes, and also inside through skylights. And you can see that if it had been an average commercial building, the roof area would have been much bigger. So it was also made possible because they reduced the overall consumption through a lot of different strategies, and I would only just mention a few of them. So it has geothermal heating and natural ventilation and passive cooling with a system of operable windows. We can do night purge in the summers or just adapt according to the inside temperature, and there is a heat recovery system. And there is obviously good insulation and that kind of other strategies. Concerning the water management, maybe the best analogy is to compare it to a forest. So if you compare it to a Douglas fir forest, the proportion of storm water discharge and water treated that goes back into the air and the soil is actually pretty similar. So 31% stormwater discharge for the Bullet Center and 39% for Douglas fir forest. So it gets all these water needs from rainwater harvesting for potable and non-potable needs. The potable needs is actually a recent achievement. It's allowed since November. Unfortunately, they had to use chlorine. They really fought against it, but the local authorities wouldn't just let it go. But it was still a big achievement because it was not allowed at first. And concerning non-potable water, water goes directly, so it's harvested through the big canopy, the big roof, and it goes into a big cistern which is pretty large, but it's due to the fact that, again, in the summer it doesn't rain at all, so you have to compensate for this. And in the rest of the year it rains awfully a lot, more than in London. And also net zero water is made possible because of low water consumption. And one of the key aspects is like the toilets. It uses composting toilets, and it's the highest building with composting toilets in the world. And with this foam technology, it actually saves 96% of water, because it only uses 2 tablespoons of water mixed with a biodegradable soap. Then it goes into the soil digesters that transform the black water into a fertilizer, and CO2 that go through the heat recovery, and leachate that goes to a facility. And finally, concerning the grey water management, the water goes through a constructed wetlands that it's built on one of the green roof, and it's treated through plants like horsetail, which are that thrives well in Seattle. And it runs several times before going to infiltration planter in the little park we can see in front of the building. This park did not exist before. It was a very dangerous intersection road, and the team managed to convince the city to change it into a public garden, and it also became part of the system of the grey water management. Martin talked a bit about the healthy materials. They also had to address this, so using only red list free materials, some salvage wood beams. All wood is FSC certified and come from 1,000 kilometer round. For here that seems a lot, but for the States it's pretty nice. And you can really feel inside that the materials are really healthy, and it's very pleasant actually to be inside. And final aspect I would like to highlight to really show that the design, sustainability design, is not just about energy and water efficiency. One of the best places to hang out in this building is actually the staircase, because it was designed with the best view, where you have like beautiful view over the Olympics, and it was intentionally made like large so people can hang out. And also worth mentioning that there is no parking space, which in the States is not the usual trend, except in New York. And 75% occupants are estimated to use public transport by walking. So there is much we could say about this building, and if you're interested about it, there are a lot of studies out there. And the main point is to show that this type of building is achievable sustainability-wise, and they did have a lot of hurdles with building regulations where they're able to tackle and change the building regulations. And now I give speaking to Aliki, who is going to present you the Birchie School.
Hello, my name is Aliki. I'm also working in elemental consulting, and now I'm going to talk to you about another living building case study, which is educational building type. So the living building science wing of the Birchie School is actually a new construction in addition to the existing Birchie School, and is the first building that pursued Living Building Challenge Volume 2, and actually the first that achieved it. The Birchie School is located in a in a very dense neighborhood of Seattle, the Capitol Hill neighborhood, and the site of Birchie School was very tight. Therefore, they knew that every single square meter of the outdoor area really mattered for the project, and the site was actually was constructed in an area that was previously a paved sport court. What is important is that as I state in the slide, the architects were KMD architects and the MEP engineers with Racing Engineering Consultancy. But what is important is that lots of green building professionals from Seattle gathered together, and they formed the Restorative Design Collective, which actually provided all the services pro bono for the project, and all the construction services, the design services were pro bono, and the construction services were at cost price. And the important thing is that design involved a lot intensive collaboration between the staff and the students of the school. The students were asked about what they would like this new building, this new classroom to look, and they answered like, I would like to have a river in the classroom, or I would like it to be like a green building. And that's how all these ideas were transformed to design features that not only met the Living Building Challenge requirements, but also provided a beauty in the building. In terms of petals, the building achieves net zero energy through the year. This is achieved through renewable energy generation from PVs allocated to the roofs of the adjacent church building. Energy demand reduction through a very highly insulated and airtight envelope, and efficient building energy systems like hydraulic underfloor heating combined with thermally massive concrete floor, an energy recovery ventilator that provides fresh preheated air in the classroom and dumps all the moist and CO2-rich air to the eco-house where the green wall can be benefited from it. And also all these are coupled with natural ventilation, which can provide some free cooling when there are temperate weather outside. In a bit more detail, from data that were gathered the year that this building was certified, we can see that the actual production, the energy consumption of the building through the year is approximately 150 kilowatt hours per square meter, which actually matches the recent data of benchmarking data of the median energy use intensity value of an elementary school in US. We can see that compared to what was designed to consume, there is a small performance gap, and this came out because of a lot of assumptions used during the design stage and not very, let's say, accurate tools, because the type of the building was not the best one to use conventional thermal modeling tools, so they used a lot of manual calculations, or they took some data from other similar studies in Seattle, or even they used assumptions of manufacturers, so that led on them overestimating the efficiency of the heating system, for example. In terms of water, the building achieves net zero water through lots of methods, such as rainwater harvesting, potable water treatment, grey water reuse, stormwater management, and black water treatment through combustion toilets. It's also calculated that the energy use of the water usage of the building is actually half of what it would be in a typical same building. In terms of rainwater harvesting, the whole cycle is visible to the students. All the hydraulic cycle can be seen from them, from the water that is collected through the butterfly-shaped roof in the building, runs through the rain leaders that are visible in the classroom, goes through the river in the floor, like a runnel that runs through the floor of the building, ends up in the potable cistern, and when this overflows, then it can be transported to the external runnel, to the rainwater garden, and to the irrigation cistern. In terms of rainwater reuse, grey water that comes out from the sinks is actually pumped to the green wall, which actually uses this the plant uses this water to grow and to be treated. And then with the process of evapotranspiration, they release all the vapor, the water like a vapor, and the ventilation system releases this vapor out of the building. Again, it is very important that the students are really aware of all this treatment and the circulation of the water, and they actually, because they know that there is a specific amount of water that the green wall can use, they are very, they take care of how much water they use from the sinks. A very important and major aspect of this project was also the health and well-being of the students, because students need an environment that will aid their performance and their creativity. There are lots of elements that provided health and well-being, such as daylighting provided from skylights and high windows, external views that look at the gardens of the buildings and the sky and promote connection with nature. Other biophilic design elements such as the green wall, which apart from treating the grey water also helps a lot on purifying the air. Also a very important aspect was the materials, and as we referenced before, everything it was red release free, which is a requirement for the Living Building Challenge. Interior finishes were limited and reduced so they can limit off-gassing. And also one very interesting aspect was that there were a lot of art objects around the building that mimic nature and can provide a very pleasing environment that brings satisfaction to students' minds. And some of these objects is like the runnel or some salmon cast on the floor or some garden sculptures. This project fits very well with the curriculum and the educational values of the Bertie School, which promotes sustainable practices and environmental awareness. It is very important that through all these processes, kids get to learn and to understand their connection to the environment and their impact on it. Some of these elements are, for example, as I said, the water flow, everything is visible. They can learn more about treatment and conservation of water. They are able to control the daylight and the natural ventilation of the building, reducing the amount of energy that they use from electric light or mechanical ventilation. The gardens help them learn more about how they can produce food, or more about botany and anthropology, as they have an ethnobotanical garden out there. Also, there is above the potable cistern, there is a water tank, a manual water tank, where the kids go and pump some water, and they then carry it outside to water the plants. And this is involved in a program called Water Fair, so they get to understand with this process, they get to understand how in underdeveloped countries people get to travel long distances to get water for their needs. And also, very interestingly, they get to learn a lot about the life cycle of salmon as they get mild and eggs from the hatchery nearby. They fertilize them in the classroom. They watch the eggs becoming fry, and then when they're ready, they can release them to the Washington Lake back again. And all this cycle goes on, and they just get to see all this every time. Oh, sorry. Last one is that there are lots of monitoring equipment across the building, and because the building needs to maintain this balance of zero water and zero energy, kids get to experience the lifetime monitoring and of air quality, energy usage and production, or water usage and production as well, and storage. And just to conclude, I wanted to say that this project is created to educate just the kids. All the sustainable features are visible and functional to them, and this is very important because all this early interaction with sustainability concepts in that early education will help them bring these values with them after school, transfer this knowledge to their families and friends, and this will create the future generation that will be able to create more inspirational educational buildings. And also, this building forms an example for the greater community, showing that this type of extreme sustainability and regenerative architecture is possible these days.